recording. But today and on Thursday, my plan is to go over problems for the final exam. And I am going to keep it short and relatively simple. Mainly because pedagogically speaking, I just don't like the idea of like, oh, here's a so I don't need like 20 questions of very simple things, because if you can write a couple larger things, you probably know how to do those smaller things. And the smaller things have been done in your runestone and in your homework anyway. So, all right. For the final exam, just to summarize, I believe it will take place in this room. I'll double check otherwise. It will be electronic. That being said, Murphy's Law is a thing, right? So for those of you who forget, Murphy's Law states what can go wrong will go wrong. Now, that being said, there are, laptops you can, borrow and stuff, but like, just in case your laptop just decides to not like you at all, I will be having paper backups. Okay. Worst case scenario, I will, and for 3 questions, that's not so bad. I've just got to write that's 3 pieces of paper on the exam. Now, that being said, what resources are you allowed to bring in? Well, it's open note and open book and open computer, but not open internet. So let me explain. Open book and open note. Anything, basically, if it's a physical paper copy of anything or printout, you can bring it in. How much? As long as you're not like piling on to the person next to you, that's fine, right? Right. So you can bring in, as long as it doesn't really require a wheelbarrow, you can bring it in. That said, I feel like making a 1 or 2 sheets of notes is better preparation than bringing in a notebook. Sorry, bringing a book, just simply because it's a lot of good preparation making that cheat sheet in the first place. Yes.
Runestone chances are notes for open note.
I will get to that, but yes, you're allowed to use Runestone. Okay, next, let's talk about electronic resources. If it's physically on your computer, you can use it. If it's on your personal cloud, like Google Drive, OneDrive, Apple iCloud, etc., like didn't name it, don't fret about it. You understand what I'm saying. If it's on your personal cloud, right, that's technically on your computer, even if you have to use the web browser to access that, okay? Furthermore, the anything that's on Canvas or linked to on Canvas or submitted to Canvas is fully good. That includes Runestone, that includes my GitHub, that includes all of my YouTube lecture videos, that includes any videos that were done as part of your any videos that are recorded as part of the modules. So that's all good. Those are all good. I'll answer when the final is in a second. I'll re-look that up for everybody. So yes, Runestone is good. Your former assignments are good. Canvas is fine. What's forbidden is basically anything that's not on Canvas or not reachable by Canvas. So no going to Google to go for Stack Overflow and stuff. No going and searching certain websites for that are yes. Documentation, you can that's probably fine, especially since you can get to that linked, and you can also download an offline copy of your documentation anyway, right?
Wait, but isn't like Python documentation something that you like search, or what do you mean by that?
Yeah, but I think it's so the reason Python.
Not that I'm complaining, but
well, no, you see, because technically Python, I have a link to the Python documentation in the syllabus, therefore it's reachable by Canvas. So similarly to the Automate the Boring Stuff book. Yeah, the main restriction I'm just trying to have is that you can't go and Google the answers, or even worse, start sending emails to other people or direct messages or the like, telling them somebody else to solve this question for you, or posting on Stack Overflow, I don't know what to do. You get what I'm saying? Or, I'm trying to make it as reasonable as possible as to what you'd be doing if you had a homework assignment you were working with, because let's face it, no programmer works without documentation, really. Okay. But at the same time, I have to have some level of restriction, because otherwise the depth of some questions becomes trivial, That is also part of the reason why I don't ask some questions like, what is the output of this code? And part of that is also because of it's just because with COVID, there's always the chance that there's another surge next week, and then some students have to miss stuff, So what about our final projects? You can use your final project, sure. But with regards to your final projects, right, you'll be submitting them on Monday. I will be the TAs will be furiously going through, and I will try to get those exemptions out as soon as humanly possible. It's going to be I've got to have a very quick turnaround time on that, because our exam is like on, I think, Thursday. So, Amul, I see you have your hand up.
I just had a question. So for the final exam, right? I think you mentioned this earlier. I just want to make sure that the 3 problems that are going to be in the exam, one of them is going to be about regex. Second is going to be about, I think, Monte Carlo approximation.
Yep.
And the third one might be you have to explain
Yep.
what the code is, or like what the.
That's completely correct. And let me repeat that for the class. Okay. So that was asking for confirmation. What are the 3 questions? And the 3 questions are going to be some kind of file reading, writing, string parsing, which becomes very easy if you've sat down and learned your regular expressions. And it's still doable if you haven't learned regular expressions. It's just a bit long. It's just like basically twice as long, which isn't too much. Then you'll also have a question that's like, here's a bunch of code. Please tell me what these things in the code do, right? That will most likely involve turtles, okay? Because that's easy to visualize, and therefore you can like say, oh, if I switch this parameter, this changes. And then the third is going to be a Monte Carlo approximation, and I will be covering one of the Monte Carlo approximation problems that I did in the past, that I've given for the past couple of semesters. Okay. So now let's go ahead and figure out when that final exam is. It should be on 4/28. So again, not a lot of time to like try to. I'll be telling the TAs that they really need to get their final projects to me basically the final project recommendations to me ASAP, and I'll be looking through them to choose my file. But let's go ahead. This is Canvas and Temple University final exam schedule. Yes, I know I'm not sharing my screen. This is in person. As far as I can tell, everything is in person. Exam schedule. Spring exam schedule. It's in person, but it's electronic. It needs to be in person because otherwise I can't proctor you. I can't walk around looking at your screens, or even worse, I can't just like stand over one student and hover over them and make them self-conscious about every single decision they've made, not only in their class, but in their entire life. And honestly, if that's taken from me, I don't know what I'll have left. So yes, I need to share my screen now. So, all right, so exam schedule according to this again, and I will send out an email with basically everything that I just summarized, just so that you will have a reference. Okay, so again, even though it says 3 credit courses, we have 3 credit lecture hours and 1 lab hour. So that's why we're down here. So 2 to 3:20, Tuesday, Thursday, has their exam on Thursday at 4:28, sorry, on April 28th from 1 to 3. Okay, If this is a problem for some reason for you, such as you have tons of exams you have to take on that day, or you get into a car accident, or you wake up sick, all right, let me know and we'll try to and we will reschedule as soon as possible. Yes. Yes, you.
Okay. I had a question about quiz 6. I know that it's due on Saturday.
Yes.
For any like errors or whatever, will you have time to break them?
Yes, I'll be manually grading that one as well. I've been manually grading the other ones because that just seems, I've realized just if I actually go through these questions now, they're actually fairly quick to go through. It's just a matter of finding the time. But yes. Yeah. So if you have an exam around that time, you're allowed to take 2 exams in one day, but otherwise, if there's a time conflict, then I will reschedule you for the exam. Yes, you had your hand up as well.
You said the room that we take this on or no?
Sorry,
What room we take this on? Is it here?
I believe it's in here. Yeah, unless we're listed down here, and I don't think we are. I think 1068, 1166, 2168, and 3223. Those have common finals, and those have a different kind of time configuration, time space configuration. It will be in here otherwise. Can you use a fancy ID like PyCharm? Yeah, you can use whatever tools are on your computer. Yeah, so PyCharm, idle, whatever you would typically use to program. Okay. No, I should have graded all of quiz 5 and question 4. If there's still an issue with quiz 5, question 4, send me an email. Yep. Final 28th, same room, 1 to 3. I will send out details. Okay. All right. And if you cannot make it for some reason, again, because you're feeling sick, please let me know. Please don't infect your fellow students with COVID or some or some new exotic disease that nobody's even heard of. All right. Send me an email if you're still having issues with quiz 5. Okay. And I will check it over. So now, speaking of the final exam, let's go ahead and jump straight to it. I'm going to go ahead and grab, not data structures, that's the wrong class. Intro to programming, and let's go and look. Oh, actually, no, we don't want to look in here. We want to look at all courses. Let's go and look at last fall. Yeah, last fall should be perfectly fine for this. Okay. And quizzes. Final exam. Okay. So let's go ahead and see what I gave. Yeah. Oh, this was last semester. This is not the one I want. I want last spring. Almost. Because I really want to just tweak my problem too. So I don't want to completely share it. It's not something to freak out about. It's literally, tell me what these things are, kind of, read code and tell me what these, how changing these things work or what these things represent, kind of deal. So, sorry. Okay. All fall 2021, spring 2021. There we go. That sounds like a good course. All right. Quizzes. Final exam from last year. Filled. Yeah, sure. If it's on your computer, it's fine. All right. So here was question 1 from, but I will do this. I'm going to go through reverse. Question 1 was our string and file processing, which is you work for a health insurance company and you want to redact a bunch of health insurance infos. We will go through that. Question 2 was, here is some code that you haven't really had experience with at all. Here's a new thing. I'm teaching it to you on the exam. That's fine though, because I give you the documentation and tell you how to use it. It's not okay. And here's the third one, which is the one that I think most people are interested in, which is the Monte Carlo. So we're going to start here and go backwards. All right. So Laser's my son, and his first board game was a game called First Orchard by Hava, which is a company that does, I think it's a German company that does board games. My very first game, First Orchard. As you can see, it's bright and colorful and has all these pieces, and I linked to it for a reason. All right, it's a very simple game. And sorry, let's go ahead. It's a very simple game, and it's intended to teach young children concepts such as taking turns in color. All right, so it's not competitive, it's cooperative. So the number of players doesn't really matter. It doesn't matter if you have 5 players or 10 players or 1 player, it's all the same player, right? Okay, the objective of the game is to gather all these fruit on the board before the hungry raven makes his way to the end of his trail and gets his way into the orchard and then gobbles up all the remaining fruit. Okay, that's the objective of the game. Gather all the fruit before you get the raven, before the raven gets there. Okay, so how's this game played? You've got 4 red apples, 4 blue plums, 4 green apples, and 4 yellow pears. You get that gives us a total of 16 pieces of fruit. To gather, how are fruit gathered? Well, the players take turns rolling the dice, and we roll this fruit die, which is different than any die we've seen before. It's this over here, this multicolored die, right? And it has 4 colors on it. It's 6-sided, has 4 colors, a basket, and a raven on it. Okay. Special 6-sided die with the following sides. Random dot choice might be helpful here. Red, green, blue, yellow, basket, raven. When the player rolls a specific color, they gather a fruit of that color. For example, if I rolled red, I'd remove a red apple from the board. If there's no fruit of the rolled color left, then nothing happens, right? So if I've gathered all of the red fruit and I roll red and somebody rolls red again, it's essentially a dead roll, right? It just goes on to the next roll. The basket's a wild card. If you roll a basket, you can gather any fruit you want. Now, because we want to automate this, you don't want to ask the user what fruit they want to remove. Instead, don't play like a 2-year-old and choose your favorite color. Instead, use the optimal strategy, which is remove a fruit from the pile that has the most fruit left, right? So we've covered 5 of the die, the 5 of the sides. The last side is the raven. If you roll the raven, it advances closer to the fruit. So the game ends one of 2 ways. You get all 16 fruit, or the raven is rolled 5 times. So, and I do have a link to the official rules. Here's my question and your assignment. How often do the players win? Calculate this by writing a program that simulates 100,000 games, right? Because we could probably figure this out with some, mad statistics skill, prob stat skills by, figuring out, hey, how many times the expected number of dice rolls for getting 16 fruit, given that we haven't rolled the raven 5 times. All right, so my rubric for this question last time I gave it was as follows. 20 points to simulate if you simulate a single game correctly. Breaking that down to 5 points for simulating the dice rolling itself, 5 points for having your code that handles gathering the fruit correctly, 5 points for handling the raven, and 5 points for running the entire game. Then 5 points for doing 100,000 games, and then 8 points for gathering that data up and calculating the win ratio. And I have adjusted this rubric throughout the various semesters, but I figured, that giving you that is pretty good. Now, that said, I do have to mention that, that you have to consider that this question has given a lot of students grief when we were not in person, because I had to do this exam online essentially, and it was essentially unproctored. And so I had a number of students submit this to Chegg, this problem to Chegg. And then were surprised when I caught them because their answers were identical to 9 other people's. And so, yeah, don't do that. Please don't do that. And then also, if you know, and this is why Googling can be dangerous, because because I've done this in 2 different semesters, this question. The other semester, if you search for orchard, Monte Carlo simulation, your first link is to Samuel Bosch, which gives you a board game that looks very similar and gives you some code that will compute it. But if you don't read it, well, this isn't the game I gave the students. The game I gave is my very first game, First Orchard. This is Orchard. And if you actually read the rules, there's 4 types of fruit with 10 pieces each, and you throw a 6-sided die with 4 colors. And if you throw the fruit basket, you can take 2 pieces of your choice. And so it's a completely different game, or at least the rules function differently. And as a result, so this is part of the reason why it's just not a good idea to just blindly copy paste code, because you never know if it's basically something completely different than what you're looking for. Because it was a different game and it was very easy to detect, especially since there was uses of lambda expressions here, which something I didn't really go over in class. Anyway, that's just my tiny rant. So let's go ahead and work on this in piecemeal. So we want to simulate this game. And so I kind of give you a rubric, which is kind of the directions for kind of how to do this. So I'm going to boot up idle. And I'm going to work on this like we would do like we would do an in-class assignment. Yes, it has to be in person unless it's arranged prior that you're taking it at an alternate time, right? The exam has to be, the final exam is in this room. I will put that in bold type in the email. Okay, if you cannot make it to this exam for some reason, then I will work on proctoring with you, but this is an in-person class, so the exam has to be in person. All right, so save. Let's go ahead and put it. I will post this recording on Canvas. So let's see. Sorry. All right, documents, GitHub. Classroom, ITP, spring 2022. I will suggest similar kind of ways to practice for the exam at the end of the lecture. So if I don't, remind me, okay? But here we go. Let's go and look for, but in general, a way I might look for that is, believe it or not, is looking at at solving questions for the AP exam for computer science. Just a thought there, since that is covering an intro class, not necessarily in the same detail or depth of the same questions. Here, actually, I'll go ahead and answer that now. First Orchard, because I'm on a tangent already. So for good resources, there's 3 I would suggest out of the box. Coding Bat is has some fairly simple questions. Coding Bat, they have some in Java, but you could try answering them in Python, and they have a bunch in Python as well. For more advanced and technical questions, I would go to Project Euler. EULER. Project Euler is a bunch of mathematical questions that require programming, a program to basically answer them. So for instance, archive. You'll need to make an account to check if your answers are correct. And you check if your answer is correct by putting the answer into a text box. It's a numeric answer. So like here, if we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. Find the sum of all the multiples of 3 or 5 below 1,000. So if statement, for loop, modular arithmetic, good practice there. And summation. Even Fibonacci numbers. Each new term in the Fibonacci sequence is generated by adding the previous 2 terms. By starting with 1 and 2, the first 10 terms will be 1, 2, 3, because 3 is 1 plus 2, 5, that's 2 plus 3, 8, which is 3 plus 5, 13, which is 5 plus 8, 21, which is 8 plus 13, 34, which is 13 plus 21, 55, which is 21 plus 35, 34, et cetera, et cetera, et cetera. This goes on forever. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even valued terms. So give me all the even Fibonacci numbers below 4 million. And give me the sum of all the even Fibonacci numbers below 4 million. This is a program, and for context, I've given like a question that if it wasn't exactly this, then some variation of this in the past. On my final exams. So these are particularly good, and they do sometimes get, but they quickly get above like stuff that you might be able to solve. They require math or a trick or something. But most in the first 20 can be figured out, except for 15, the lattice path. That one can be a bit much. But they're good practice problems. They're good for getting your brain working. And finally, advent of code, going through their archives, which are a bunch of coding. So this comes out basically every December, and it's basically only you, the programmer, can save Christmas for the elves and Santa Claus by completing these 2 daily programming challenges. Going back to and you can basically review these. It started a number of years ago, and there are a bunch of fun themed problems. So I find those to be good general programming questions. In general, though, go and otherwise look in the Automate the Boring Stuff book and look at some of the projects or something for that to get some practice. All right. So let's go back to our assignment. Okay, so 5 points for simulating the dice rolling. So the first thing we should do is obviously write a dice rolling function, right? Def roll, I'll call it roll, takes in no arguments. And so basically, so I will leave this one to you to figure out for I'll give you a couple minutes to figure it out. But let me drop you some hints. First off, we want to import random, right? Because we're rolling stuff. Anything basically doing with Monte Carlo, you're going to want randomness. Okay, next, this isn't your standard 6-sided die. You could return 1 through 6, but that gives you more work later on. Because then you have to remember, is 1 red or is 2 red, right? So instead, I'd create like a list of all the options and then randomly choose one of those options and return it. All right? It says random.choice might be helpful there. So go ahead and take a couple minutes to complete that function. It should be fairly short. All right, so if you're stuck on it, what you want to do is you want to create a six-sided, basically a list of 6 items, with each item being one of the choices, and then return random.choice on that list. Do people need more time? Okay.
To create a function, right?
Yep, you want to create this roll function. You can do it in one line, but one line is going to be, but if you do it in one line, it's going to be long. All right. So, because we only have so much time, let's go. So the way I would do it is I'm going to create now the order of the list shouldn't impact the way this works out. So red, and you could use RGB. I'm just going to be red, green, sorry, red, blue, green, yellow, raven, basket. All right, so those are the sides. Now to roll the die, what are we going to do? We're going to return so that we get an answer out of this function. Random.choice sides. And what random.choice does, if you remember from our documentation, what that does is that selects one random, one at random from here, and everything has an equal chance of being chosen. And we can test that by basically printing our roll over here. So we can call roll green, blue. So it's going to come back with different things. Raven. Okay. So next, unfortunately, we can't avoid getting too big. And what we're going to do is we're going to create a separate function for the game, def game. Okay. So because the next point is to handle the fruit. Okay. So we need to figure out basically what our terminating condition is, but we're going to need some while loop to go around to iterate this game. So when I'm starting up like a game, we know that basically how we're going to do this, which is so let's see. So before we figure out, we're going to need a while loop. And I always like to if I know I'm doing a while loop and I'm not completely sure of how I'm going to write it, I always like to write while not done, do the stuff. The pass again is just something I put in so that my code will work if I run it, even though it will skip over it. So while not done, and then done is equal to false over here. And then when we're done, when we can figure out when we're done in the loop and switch done equal to true. Make sense? Or we could run this loop forever and return true or false based on whether or not the players won the game. All right. So what variables do we need? Well, we have 16 total fruit, but we need to keep track of them individually. Like not each individual piece of the 16 fruit. Although we could, there's a lot of different ways to do this. But the point being is you can't just have a single variable saying, like, you can't have just 2 variables like this. Fruit left is equal to 16 and raven left is equal to 5. You can't have 2 variables like that because, right, if we roll red and we don't have any red fruit to take, we can't do that. We can't take it out. Okay, so there's a couple ways to do this. The first is to have 4 separate variables for the fruit. Basically say red, R is equal to 4, G is equal to 4, right? You know, have 4 separate variables for each of them. This one is, I have opinions about this one. There's another way we can do this one. But that's basically, so that one's, it works, but it's not, it doesn't make your code as simple as it could be, okay? Another way we can do this is that we can we could track each single fruit individually. But we're not going to create 16 variables for that. We'll just create one. We'll create something called fruits, and that's equal to, basically we'll create so R, G, B, you know, we could create R, G, R, B, Y, G. Actually, let's go ahead and do this red, blue, because, well, look, trust me when I say it will be easier if I match what I wrote up there. So make it match whatever you put in your code. And then, or yellow. Okay. And then rather than being, I could either, you know, use multiplication on that and multiply by 4, or I can just copy paste a bunch of times. So comma, boom, comma, boom. Red.
I have a question.
Yep.
Why do you need the expanded list again?
What, this way of doing it?
Yeah, the fruits list. Why does it need to be expanded?
What do you mean expanded?
As in you have like red, blue, green, and yellow 4 times.
Oh, because I have 4 reds, 4 blues, 4 greens, and 4 yellows. And so what I can do, and so doing this approach, how would this work? Basically, the way it would work is that, well, what I'd have is in my game, well, and the first thing you want to do, so let's just move from here for a second. What I can do is I can say roll is equal to, I can, or rather, let me go with result is equal to roll. So that way I don't have, I don't overload my function call, you know, or the syntax. So result is equal to roll. And then I can say if result in fruits, so if the result was one of the colors that's in there, I can then try to remove it, right? And I believe, let's see, let's go to our docs for list, docs, list. Yeah, you should be able to do that. Although you'd want that 4 to be outside of the, you don't want to put them in parentheses. You don't want it nested like that. That would be not great. So doc list Python. So just, I believe you have to use del, but let me just see. Remove, oh, nope. Yeah, there we go. Remove the first item whose value is equal to that. Excellent. And then you get an error if there isn't that item. So basically what we can say is, so for this one, the way we do, if we do it this way, it's actually fairly straightforward. If the result is in there, if I roll the die and it's in there, okay, then all I have to do is fruits dot remove the result. Okay. Else, or elif, the result is equal to basket, then we'll have to, that's something else we're gonna have to figure out, right? Okay, so pass. And then elif raven left is equal to, if result equal to raven, then we'll handle the raven. Make sense? So why are we removing it? Well, because what you do in the game is that when you roll the die, you remove the piece from the board. So this would physically simulate that. And then we can tell if we're done in two different ways. Okay. And then, so what are the ways we can tell that we're done? We can tell if we are done by if the length of the fruit equals 0, or raven left equals 0. Done is equal to true. Make sense? Yes. And another question is, couldn't I have just multiplied fruit by 4? Yeah, but I'm not expecting you to necessarily remember that in the middle of an exam. So the question is, couldn't I have done that? And the answer is yeah, I believe so. I believe that should have done 4 independent things. So we could have done that. All right. Now, regardless of how we do this, by the way, regardless of whether we use a list of fruits or 4 fruit variables, this part essentially is going to be the same. Okay. There is one other way to do this, which is that you can have a dictionary. And you can say, and instead what we can do is say fruits is equal to red has 4 left and green has 4 left. And now the only thing with that is that over here, instead, what you'd have to say is if result in fruits, right? So if it's a key in there, basically what we'd have to ask ourselves one more if statement, which is if fruits of result is greater than 0, then fruits result minus equals 1. Okay. So we'd subtract, basically we'd say, hey, if we rolled something that was a fruit, go to the key and subtract 1 from its respective value. And then over here, rather than doing length of fruits, what I would be doing is sum of fruits dot values. Right, the sum of all the value of all their values. I'd get the collection of all the items that were there, but as you can see, that's a bit more gritty. So I do like having basically this physical representation of all those pieces. So because it also avoids the need for an if statement. All right, fruit. So I'll do this and I'll do fruits, but there's a lot of different ways to do this, is the point. Fruits dot remove. And you could just simply have an if else statement for each color and then have 4 variables representing each one of those colors. There's nothing stopping you from doing that. Fruits dot remove result. All right, to handle the raven, that's fairly straightforward. If I roll the raven, the number of raven left is minus equal. And the reason I'm counting down here is because we notice that we're going to 0 for both of them. It's just easier if we don't try to confuse whether we're going up or down. If we're subtracting, we want to always be subtracting for all cases if possible. Just a stylistic thing. Okay. Okay, and then finally the basket. The basket is the last thing to simulate, which is that we have to take the one with the most in there, right? So this one is a bit trickier. There's a couple ways to do this. But you know, for each of these, we can count them. What does the times 4? It creates 4. Here, I'll show you. Options, Python shell. It replicates, right? If I did this for any collection, we can replicate. If I did A times 5, it would give me 5 A's in a row. So rather than copying and pasting it a whole bunch. So we get the roll. So now the basket. Couple ways to do that. Okay. One way we can do this is we can have so this is one way that just kind of came to me right now, which is to have counts, which is to have fruits dot count. So what is it? So let me go ahead and go into here to make sure it's correct. Yep, count the number of times each of these appear in the list. Right? Fruits dot count red. So actually, let me go ahead and grab this, copy it down here, and just fruits dot count, and I will just simply fruits dot count the number of times the red appears, the blue appears, the green appears, and that would give me the counts of each of them. I could create a dictionary to figure that out, but now that we know, we can probably go somewhere with that. So now that we have those counts, right, what is the best way to deal with it? So I could figure out the way I think of doing this, that's kind of the most brute force way, is basically most left is equal to max of count. So this tells you which is the biggest number of stuff we have left, right? This one will tell you, hey, you have this many red, this many blue, this many green, and this many yellows left, okay? Then I want to know which is the biggest pile, but that doesn't tell me what index that's at. In other words, whether it's red, green, blue, or the like. But what I can do is now I can grab counts dot index of most left, and that translates it back to, well, 0, 1, 2, or 3. And again, brute force way of doing this, the inelegant way of doing this, which I'm just going to leave here for right now, is if most left, if most left is equal to 0, then first that remove red, because that was the order we did it in. Red, Again, I'm not really trying to be elegant anymore. 1 blue, 2 and now over here, so red, blue, green, and yellow. Okay. And that basically will just remove the one that has the most or is tied for the most. Okay? Make sense? So here, what does this do? It tells me I basically arrange to a list that counts all of them. I figure out which one of them has the most. What's left? Sorry, counts.index. What's left? That's not right. Sorry. Got ahead of myself. I used the wrong variable. Or no. I could just. There. If counts.index of most left. So basically, if I found the most left was at index 0, that was this. If I found the most left was blue, it was this. So I should remove that. Otherwise, I should remove green. Otherwise, I should remove blue. So there we go. That is the last 5 points, which is handling the basket so that all the fruit are handled properly.
I have a question.
Yeah.
Technically for this, you could just do like, if you instead do like fruits dot remove fruit bracket counts dot index most left, right? You could do that.
Yeah,
too.
you could do it. You could probably, yeah.
Okay. I just wanted to make sure.
I think, well, because the index, actually, no, because we don't
Is it
know.
like-
We have to specify here because we didn't have a linking from 0. We didn't have anything in the computer linking 0 to red and 1 to blue and 2 to green.
I see. Okay. Okay, but like if you, for example, like, you know what I mean? If you say like, if you do the index, right? And then you have the number and then like you put in like fruits bracket that number, right?
Oh, well, the indexes will change as you're removing stuff.
Oh, okay. That makes sense.
Mhm. That's part of the reason why I'm doing the whole remove thing. I'm letting the computer figure out where to remove the item from.
Gotcha.
Okay, so now when we're done, we either have fruits is equal to 0 or raven left is equal to 0.
I have a question as well.
Yep.
Wait, when you're doing the count of red, if it's 0, like what is it? Like, wouldn't it mean there's no red already? So what would be the purpose?
There's no reds here, but count being index 0, meaning that this has the most. So this is the number left. This is the right. This is the number left. This tells me what index the most left we're at.
I see.
Make sense?
Yeah.
And if the most left were at 0, that doesn't mean 0 was the most left. This means that the index with that had the highest number was at 0. Make sense?
Yeah.
Okay, so my question is technically, right? If you created a separate list with just
Yes.
those 4 colors,
Yep.
and you indexed it off of that list, that wouldn't change. So that would be okay, right?
Yep.
Okay.
Like I said, I was just trying to spit out the code as quickly as possible for this
Yeah,
section.
no. I was just wondering, because
Now, so now that we're done, this while loop is done. So now we have to tell whether or not the person won the game. And we can do that with one statement, which is return length of fruits equal to 0. If that is true, then the player won the game because there were no fruits left. Otherwise, it returns false, which means that we quit because the raven's left was equal to 0. No need to check if the raven's left was equal to 0. Because if it's the raven's left was equal to 0, done is equal to true, but this wouldn't have been 0. So this will return false. So let's go ahead and just run the game just to make sure that I don't have a weird, funky infinite loop here. And this will tell me true if the player won and false if the player didn't. False, the player didn't win. Let's run it a couple times. True, okay, so we do get true and we do get false. Okay, so the game runs, but let's go ahead and I'll be sharing the full code later, okay? And I'll be uploading it to GitHub. Okay, so now that we've got this, let's go ahead and do a Monte Carlo approximation. So we want to do 100,000 trials of this game. We want to run this game 100,000 times. And what I need to count is the number and what I'm trying to figure out is how often the players win. Wins is equal to zero. So I'm going to put in a bunch of other stuff, but at the end of the day, what I need to calculate is wins divided by trials, right? That's all I need to do. So for in range trials, what am I going to do? I'm going to run this game. Result of game is equal to call the game. If result equals true, which I could just shorten to if result, but again, easier if I could just to be more clear here right now. If the result is true, then wins plus equals 1. Don't need to keep track of the losses. Why? Because if I was really interested in the losses, all I'd have to do was subtract the number of wins from trials, and that would give me the losses, right? And so now if I run this, I get 0.63, which from me doing this a bunch of times, I know is the answer, by the way. So the game players win about 63% of the time, which is pretty good win ratio for a bunch of kids, right? Like, so if I wanted to get the losses, what I could do is that all I would have to do is do trials minus wins divided by trials. Just a bit of simple subtraction there. Because anytime you didn't win, you lost. There is no tying in this game. So, and we played 100,000 games. If I play 10 games and I won 6 of them, that means I lost 4 of them. And I know that because of subtraction. Right, the only difference here is that we're dealing with much larger numbers, that's all. And when we use much larger numbers or variables, suddenly things become scary and abstract. So again, there's a whole lot of different ways to do this question. A whole lot of different ways. See, so first orchard, haha. No, that's just sending it to one person. Here, I'll go ahead and drop it in chat. But again, for everybody else, I will send this out in an announcement later as well. But somebody asked that I drop it in chat. Okay, so that was the Monte Carlo. So what kind of other questions might we expect and that I might go over later? So you might expect something along the lines of how many, if I've got a game, another kid's game where I'm trying to get to the, where I'm trying to get to the end of the board, either like via Candyland where I'm taking things off the top of the deck and moving stuff, or if I'm just rolling die, then how many rolls will it take to get there? Or if I shuffle a deck of cards and draw some cards, what is the probability that the thing on top of the deck is what I want it to be? Make sense? Right? If I say that I'm playing, so example of that, suppose I'm playing a game of poker, right? and I deal out the cards, right? What's the probability that the card on the top of the deck is a red card? Make sense? And so in that case, you don't have to worry about a full deck of cards and all the suit. You just have to know the fact that, and I'd mentioned that half the cards in a deck of cards are red, half of them are black. If we deal out the cards in this manner, what's the chances that the next card is what we want it to be? Make sense? Or maybe it's a more uneven kind of thing. Or maybe I might give you the choice of doing two problems, because I don't know, because I'm crazy like that. Who knows? All depends, but it will be some kind of game. There will be either, and the randomness will either be dice rolling or card drawing. Okay, make sense? And now what it won't be is as simple as rolling one six-sided die. Okay, because rolling, because that's, or sorry, one regular 1d6, right? This was a six-sided die, but there was nothing regular about it. But if I give you like a regular 1 to 6-sided die, I'll probably have you roll two of them, two six-sided die, because that gives you a different distribution. That gives you a normal distribution. It also means that you have to register knowing that, oh, I just can't multiply the result by 2. I have to roll 2 physical separate die to do this. All right, so let's go ahead and look at this problem. So this is kind of an example for the second question, which is probably the least you know about, which is basically I like to sometimes test. I'm probably not going to do it this time, but I like to sometimes test like, hey, here's something new. Have you learned how to learn? Have you learned how to read what I give you? Have you learned how to read the instructions? A very, very important kind of concept. So let's take a moment to learn about a set in Python. A set is one of the built-in collections. It is a special way to store items, and it has 3 rules. They are unordered like dictionaries. You can put items into them, order doesn't matter, right? Make sense there? So lists, order matter, sets don't matter. You can think of sets like being a straight line of stuff, everything in a row. And you can think of, you can think of lists being straight, queue, everybody lined up nice and orderly, where sets are more like that pile of stuff you just throw everything onto and then you have to dig through to find anything, right? So as a result of the first rule, they don't have indices. They don't have an index. You can only tell if something is in the set by iterating over it or asking, hey, is X in the set? And finally, the most important thing and what makes them actually useful, sets contain unique items. You can't put something into a set twice. If you try, it's just going to go, ha. These are just like mathematical sets. If you learned about sets in any kind of abstract mathematics class or your intro to computing concepts in computing class, this is exactly what they are. These are mathematical sets. And in mathematical sets, you don't care, you just care whether it's a list of things in the group. Either you're in the group or it's out of the group. All right, so let's assume we wanted to make a set called S. Here's the operations we would need to know. S equals set with parentheses is how you make a set, okay? Adding something to a set is as simple as going, hey, I've got a set now, let me add that thing to the set. That's it, that's all you have to do to add to the set. If it's already there, it won't even crash, it just won't do anything. Right? So we can try that out. So, and if I were you, I would if I was doing this on the exam and I got something like this, I would follow along with that. Okay, so set is, so S is equal to set. Oh, that didn't crash. Okay. S is equal to set, assuming I can type. That didn't crash and burn, okay. S is, okay, tells me it's a set. S dot add an element to the set. Okay. Let's add apple to the set. S dot add banana. Okay, there you go. Banana, apple. Looks a lot like a dictionary with only the keys. And finally, S dot add apple. If I try to do that again, right? It doesn't change, right? It just doesn't, if it's already in the set, it rejects it. Make sense? Okay. Then two other things. How do I know if something's in the set? Use the in operation. Apple in S. True, because the apple's in there, right? Okay, what about pear in S? False, it's not in the set, it's just banana and apple. And finally, the fourth thing, because these are the only real four important operations, we don't have to worry about removing things from a set. Not for this kind of context. That's, you almost never remove things from sets. S, to tell, how do you tell how big it is? You figure out the same way you figure out how big everything else is in Python, using the len function. 2 items in the set. That's it. Okay, so what do we actually use these things for? A set is useful when you want to quickly keep track of the things you've already seen. So sets are extremely useful in graph theory problems when you're doing like depth first search or breadth first search, and you don't want to travel to a destination you've already been to, right? So you can keep a list of things you've seen, the places you've seen, so you don't travel there again. You don't care when you saw it or how many you saw it or where, you just care, have you seen it or have I not? It's also useful for keeping track of how many unique things you've seen. Sets, by the way, you don't need them. You could just simply use a dictionary and either have just the key and whether or not the key is in the dictionary. But by simplifying the number of operations, it simplifies basically the code. So what's our question then? Well, it's probably related to sets. Write a function called unique words file name that, given a file name, returns the number of unique words in the file. You can assume all the words are lowercase, that there are multiple lines of text in the file, and that each line has multiple words separated by the space. Finally, you can ignore punctuation in your code. For example, this input should yield 14 as there's 14 unique words. So here, and so in a lot of cases for the final exam, what I will be doing, by the way, is I will be giving you input files, example input files, and example output files. Now, like over here, for this input file, this would yield the correct output. That said, and if you can get the correct output, then your answer is most likely correct. But like, it's not going to be 100% correct because you can, if somebody, right, if you simply just write code that says, write out all the contents of the output file as my answer, right? Then that's not, yes.
So just to clarify that, so you'll give us the output file to show what should print, and then
Yes.
we use like our idle or is code like,
Yes, to check your answers.
and then we just copy and paste our work
Mhm.
into like a text box or something on Canvas. Like,
Yeah, so you basically just drop your code, you just basically copy or paste. So these are quote unquote essay questions. And what you do is you just simply copy paste your code into the text box.
Okay.
And then anything else you can, and then I'll have I believe I should have I have some other places where that are empty questions for you to upload any code that you have. Just in case you're paranoid about your code being damaged in the transfer. Yeah. So you'll have the ability to upload your code so that I can look at it and download it if I need to run it or something. But anyway, so here's our input file. I like to eat apples and bananas. I like to eat apples and bananas. This is a rather silly input file. Okay. You can tell I was living with a very young kid when I wrote that. Okay, so this should yield 14 because there are 14 unique words. Bananas eat, silly A, input this, rather apples like file 2, and is I, right? So there's that many files. So again, what I've done here is I break down the point values. Opening and reading the file, 5 points. 10 points for writing the function. Correct, basically, okay, did you put this in a function? Does the function make sense? Or do you actually, can you write a function for God's sake? You'd be surprised how many students don't follow the direction there. That's why I put it specifically in the rubric. 10 points for parsing each individual word in the file. And then 10 points for actually counting the unique words. How many unique words? So 10 points for using the set, 5 points for opening and reading the file, 10 points for parsing each individual word in the file. So this one, we have like 10 more minutes. So let me go ahead and get to it. So new file, I'm going to call this how to use sets. Okay. And now what I'm going to do here is def. And what was the function called? It was unique words. Whoops. Yep. Unique words. File name.
Question.
Yep.
What exactly was the question about? Like,
how many unique words are in the file?
oh, in that specific file that you mentioned.
Well, no, in any given file. So not in this specific file, because I told you there's 14.
Okay.
I'm saying if I tested this on any given file, tell me how many unique words there are.
Oh, okay. So you write your own code to determine.
You could, yeah. So you could write your own test case, but the idea here is that like I give you a test, an example input and output.
Okay.
Be clear about what I want. And like I said, with this one, I mentioned that you can assume all words are lowercase, even though I didn't. Whatever. In other words, you don't have to worry about case. Each line has multiple words, and notice that there's no punctuation in here. In other words, don't worry about punctuation. Just worry about going through and counting the numbers, the words. So file name, lowercase that. So first thing we have to do is open and read the file. So no, you didn't need to do a try catch or anything like that. You can assume that the file being passed to you is fine. So open. Let's go with file name. R is equal to text, and then rather than reading it, I'm just gonna go and straight hit the for loop, which will read it. Or I could do actually I'll go ahead and just do this. I'll do it. Lines is equal to text dot read lines. This reads the file as a list of lines, or line in lines. And this is just my preference about how I do it. There's tons of ways to break this one up and parse it. For each line of text in the lines, then what we want to do is we want to split it up into the words. Find out split. That splits over the white space. And now for word in words, and some people hate this It's just the way my brain works, where I always do the name as for the singular in the plural. For some people, that doesn't work. If you're one of those people, then do something else. If you're one of the people that this doesn't work for, then do something else. So for word in words. Okay. So now that I've basically gone through this, now I got to start counting these. All right, why is everything okay? Weird. I over indented, so let's fix that. Okay. So now we need to count the number of unique words. And the way we do that is that we create our set. And then s dot add the word. Now we could technically ask if the word is in the set, then add it. But we read the instructions. If you add a word to a set and it's already in there, it's not going to add it to the set. It's just going to ignore the word if it's already in there. So for every word, add it to the set. And then return length of S. So that's fairly straightforward there. So let me go ahead and save this input. Go to Documents, GitHub Classroom, ITP, Spring 2021. Okay, and now I will go and now that's in the same folder, I'll show that this one works, which is by print unique words. And the file name for this particular file was input2.txt for this particular exam. But the point being is that it's not hard to create on your own, but you can see it's 14. And you can basically do this for pretty much any file. But it's fairly straightforward how to do this once you basically understand a set. So if I introduce something, how to use it, if I introduce something new, I will tell you how to use it in as much, and it's not going to be like something like super difficult, like, or obtuse. It's going to basically say, hey, here's a variation of something you already know. But honestly, I like the one I did. I did in the past semester. I like the question I came out with last semester, which is, hey, tell me what this code does, or tell me what, or rather, the one for last semester was, here's a bunch of code. And I have like 6 questions in the comments of the code saying, hey, what does this line do? What does calling this do? If you give it with different parameters, how does this change? You know, tell me what this changes, you know, except that everything is disgustingly written in the sense that the variables names make no sense and the function names make no sense. They're not like contradictory, like I don't write red and then it draws blue. It's just gibberish. Yes.
Just to clarify, are any of these practice files that we use in the example, are we not allowed to, like, we practice?
Yeah, just totally. All right. So I'm gonna, before we leave, I'll just let you glance at this last one and think about how to do it. Suppose you work for Insuricare, a health insurance company with a completely soulless name. Your only solace while working to this company is you suspect the large man in the cubicle next door might be a retired superhero. That's a reference to the Incredibles movie, by the way. Insuricare is the company from that movie. Anyway, you need to release some emails, but want to make sure things are redacted. Write a script or function that, given a file name, reads the contents of the file and creates a new file with all the patient ID numbers redacted. Insurecare's patient ID numbers look like these examples, and I actually had a typo in here that they fix, which is that this did not have a dash in it. The A should have a dash. So it looks like this, or this, or this. Specifically, They begin with a 2 or 3 character alphabetic part and are followed by a 12-digit numeric part. The alphabetic part and numeric part must be separated by a dash. So they're supposed to be a dash after the ace. THX dash and dash. And additionally, the 12 numerical digits will either be grouped together or separated into 3 groups. Sorry, 3 groups of 4 separated by dashes. So see, all the 12 numbers are here grouped together. And these are split up, but you're not going to get like 4 and 8. You're either going to get 12 or 3 4s. Make sense? And then so again, yeah, I think you could use the regx or you could use the regx website if you wanted to. I don't see why not. So here, this so anyway, like here, all of what we can see here is that the input IDs, right? Now, this is the input file, and the output file basically removes only the things that match the numbers over here. Okay. So the idea, given this input file, you should receive this output file. So the idea here is that if your code works on these, it will you'll most likely get 100. But again, no tricks of like, okay, I just make a program that prints this out. I'll look at that and just give you a 0. Like that just simply just writes this as the output file. All right, so again on Thursday, so yes, class is over. While you're headed out the door, last couple things. Yes, class will most likely be virtually on Thursday, for reasons I explained earlier. Furthermore, I will get your exam, your projects are due with a hard deadline on the 25th. So because I have to get them graded, I have to figure out who's got the best ones on Tuesday. Not necessarily get them graded. I just got to figure out what the best ones are. Okay. Be sure to turn in your progress report if you haven't. And yeah, I look forward to seeing what you created. And yeah, if you're having trouble with your project, that's okay. Again, it's all about what you learn. Okay.
Professor,
Yes.
Regarding
Um,
projects, so you said you need to be able to download it and actually run